If your teen knows basic Python, this may be the moment to stop buying more beginner Python courses. Here is the test. Give them a blank screen and ask them to build a small game, simulation, or data project without starter code. Do they make a plan and begin? Do they test what happens? Can they explain why the program failed? Or do they wait for the next tutorial to tell them exactly what to type? Those two students may know the same syntax, but they do not need the same next step. In this video, I will show you 3 pathways after beginner Python, and the simple readiness signal that separates them. A student can know variables, loops, functions, lists, dictionaries, and classes and still struggle to create something of their own. That is not a failure. It simply tells us what should come next. At Pristone Academy, every meaningful build includes 4 behaviors: predict, test, debug, and explain. Can the student predict what the code should do? Can they test whether that happened? Can they debug the gap? And can they explain the result in their own words? That cycle matters more than the number of Python chapters completed. Independence is the goal, not just finishing the curriculum. For an upper elementary or middle school student, the next step may be to make code visible. This is where syntax becomes a system. Build a game with state, rules, collisions, and scoring. Use object-oriented Python to organize a larger program. Create a maze-solving agent or a strategy bot that looks ahead. Then move code off the screen with an Arduino, sensors, lights, buttons, or a robot simulation. This is the route used in Pristone Academy's AI Advantage track. Understand how the machine works, strengthen Python through games, and connect code to hardware. The goal is not to decorate a resume with AI. The goal is for the student to build a system they can explain from input to decision to output. It's about true technical agency. For a high school student who already builds comfortably, the next step may be the AI technical track. Now the questions change from how do I build this to how does the model learn? What is supervised learning? How is regression different from classification? Why do we separate training, validation, and test data? The student works with tools like NumPy, scikit-learn, and TensorFlow, but the tools are not the point. The point is judgment. Can they compare a model with a baseline, diagnose bias and variance, explain why a result improved or why it did not? They should take one algorithm end-to-end on a dataset they choose, pause, and choose the closest description. Student A can follow lessons but freezes at a blank screen. Student B can build and explain, but hasn't learned to evaluate models rigorously. Student C can establish a baseline, run a fair comparison, document failure, and state what the evidence does not prove. Student A needs ownership through building. Student B may be ready for deeper machine learning, and Student C may be approaching research readiness. Choose the path that matches their signal. Research is a different kind of work. It isn't just a larger project. It's about investigating a question whose answer is not yet known. Pristone Academy's Research Mentorship track takes one question through 5 phases: groundwork, method, the full build, analysis, and finally the written report. It is deep, intentional work. The standard is one project the student can defend end to end. We aren't looking for a collection of artifacts. We're looking for mastery over the unknown. So what should your teen learn after Python? If they still depend on tutorials, give them smaller original builds and make them own prediction, testing, debugging, and explanation. Ownership is their first hurdle. If they build independently, teach them models and data discipline. If they can already evaluate and are ready to investigate the unknown, then research may be appropriate. Age is a factor, but independence is the true signal. If you are not sure which pathway fits your student, Pristone Academy begins with a diagnostic. In the AI Advantage track, the first session includes an immediate working success so the student leaves confident. We look at coding experience, math comfort, and most importantly, how the student responds when the next step is not already written down. From there, we find the perfect fit for their growth. The right next step is not the most impressive sounding label. It is the next level of work the student can build, test, explain, and own. What are they ready to own next?